let's take a look at a couple of examples here. In this example, question says, find the probability of a normal distribution. A survey indicates that people keep their cell phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will keep his or her cell phone for less than 1 year before buying a new one. Assume that the length of the time people keep their phone are normally distributed, and they are represented by variable x. Very good. So let us take a look at our board, write down important information, and identify the case. So in this case, what do we have? First of all, we have a normal distribution. That's for sure. We're going to interpret what do we have, convert everything into mathematical form, and start solving this example. So this example says we are working with cell phone users, and we are interested in knowing that, well, what's the probability that they keep their cell phones for less than 1 year? So what information are given to us? Information. What is the mean? What is the standard deviation? And what is the type of variable that you're dealing with? Is it discrete or is it continuous? So what's the mean of this data set? The mean says I have 1.5 years. What is the standard deviation? 0.25 years. Is this discrete? Is this continuous? Question says, hey, I have a continuous random variable. So now what type of probability am I looking for? Question says, find the probability that they keep their cell phone less than 1 year. So keep the phone less than 1 year. Less than 1 year. Very good. That's the meaning of that. Less than. X is less than 1 year. Quickly graph it. What's the graph like? The graph is, well, I have a normal distribution and the mean is 1.5. So 1.5 is located in the middle. 1.5. So standard deviation is 0.25. We can divide this up using the standard deviation. Well, what is the probability? The probability of x being less than 1. X being less than 1. Suppose your 1 is here and you are looking for this area, this probability on the left hand side. Hey, I have P of x less than a. Let's take a look at our calculator. Calculator says if we have a normal distribution and we're looking for P of x less than a, less than or equal to a, it's going to be second. Vars normal CDF, the lower limit is going to be a number on the left hand side. a very small number, like negative 100, negative 1,000, negative. And upper limit, your upper limit is 1. We want to know what is this probability, what is this area. Lower limit is negative 100, negative 1,000, if you want to be safe. And your upper limit is 1. So 1. What is the mean? Mean is 1.5. Mean is 1.5. What is the standard deviation? Standard deviation, sigma is 0.25. Let's take a look at our calculator. This is my calculator. I have all the information. Let me turn on the calculator and let's go. Lower limit is negative. Guys, for negative, do not use subtraction. This is the negative sign. Negative 1,000 or negative 100. And upper limit is just 1. Mean is 1.5. And standard deviation is 0.25. Well, let us calculate this probability. This probability is, well, 2.28%. This probability is approximately, write it as 0.0228 or 2.28%. So the probability that a person, if you randomly select a person and that person keep the cell phone for less than 1 year is 2.28%. The probability that a random person keeps the phone for less than 1 year is small. It is 2.28%. So if I ask you to find the probability that a person keeps the cell phone for less than 1 year, P of X less than 1.5 years, what is that probability? What's the meaning of this probability? It means that, hey, we are looking at normal distribution. We know that the mean is 1.5 years, am I right? This is 1.5 years in the middle. It says, hey, what is the probability that a person, that you randomly select a person and that person keeps the cell phone for less than 1.5 years? It means that you're looking for the area on the left-hand side. What's the total area? The total area is just 100%. Half of it is 50%. 50%. So the probability, we don't even have to use the calculator. By looking at the graph, since it says less than 1.5 years, 1.5 is our mean. Mean divides the normal distribution in half. So it's going to be just 50%. Or 50%. It means that the probability that you randomly select a person and that person keep the cell phone for less than 1.5 years is 50%. It means that after 1.5 years, a year and a half, that person might end up buying a new cell phone or keep that cell phone. Let's take a look at another example. In this example, we have the following information. Guys, read this carefully. A survey indicates that for each trip to a supermarket, a shopper spends an average, guys, we have the keyword average, 45 minutes with standard deviation. The standard deviation is also given to us, 12 minutes in the store. We have all the necessary information that we need. 45 minutes as the average and 12 minutes as the standard deviation. the length of time spent in the store are normally distributed. Do we have a normal distribution? Yes, of course. And they are represented by variable x. A shopper enters the store. Find the probability that the shopper will be in the store for each interval of time listed below. Interpret your answer when 200 shoppers enter the store, and how many shoppers would be in the store for each interval of time listed below. So first of all, you have a shopper coming to the store and they spend between 24 to 54 minutes. What is that probability? You are opening a store and you're expecting to calculate this. How many shoppers will be in the store? Do the store have the capacity to hold all of those shoppers in the store for 24 to 54 minutes? What if a shopper enters the store and spends more than 39 minutes? What is that probability? Well, very good. So let us identify important information in this question, then use our calculator. So in this example, we're dealing with shoppers in a store. Shoppers. First of all, the question says, hey, I give you the average, I give you the mean. The mean is equal to 45 minutes. I give you the standard deviation. Standard deviation is 12 minutes, am I right? So it says, now a shopper enters the store. You have a person, a shopper enters the store. What is the probability? A, what is the probability that that person spent between 24 to 54 minutes in the store? B says, well, what is the probability that that person spent more than 39 minutes in the store? So again, X is larger than 24, X is less than 54. What is that probability? Well, to find the probability, first graph it. Try to visualize what's going on. It says, hey, we have a normal distribution. It means that we have a graph, bell-shaped graph, symmetric with respect to the mean. What is mean? Mean is just right here, 45 minutes. 45 minutes with standard deviation 12. So if I add 12 to 45, I get 57. Then if I add 12 to 57, I get 69. If I add 12 to 69, what do I get? I get 81. And on the left-hand side, we start subtracting. 45 minus 12 gives us 33. 33 minus 12 gives us 21. And 21 minus 12 gives us 9. So it says, here we have the following. The probability that X is in between 24 minutes to 54 minutes. 24 minutes. Well, 24 minutes is about here. 54 minutes is about here. Okay. So I want to know, what is this probability? What is this area? What is this guy? So since it's a normal distribution, I'm going to use my calculator. But what is the lower limit? What is the upper limit? The lower limit is 24 minutes and the upper limit is 54 minutes. Upper Well, my calculator, second VARs, normal CDF. There you go. So turn on your calculator, second VARs, normal CDF, and lower limit is 24. So enter 24 for the lower limit. Upper limit is 54. Enter 54 for the upper limit. Then mean is 45 minutes. Standard deviation is 12 minutes. Enter everything correctly. Then do the calculation. The probability is 73.33%. So this probability is 0.7333 or 73.33%. This is the probability that a person enters in the store and spend between 24 to 54 minutes in the store. Very well. So what do we have here? What is our graph? Our graph is, well, here we have the following case. It says it is larger than 39. What is the mean? Mean is 45 minutes. 45 minutes. 39 is on the left-hand side. 39 minutes. We're looking for this probability. What is this probability? So to find this probability, we're going to use our calculator. Second VARs. Well, find normal CDF. Okay, let's second VAR, normal CDF. What's my lower limit? My lower limit is 39. Why is that? Because 39 is on the left-hand side. This is my 39, the lower limit. What is the upper limit? Upper limit is a positive number, large number, like 100, like 1,000. So I have my lower limit and I have my upper limit. The lower limit is 39 and the upper limit is 1,000. Mean stay the same, 45 minutes. Standard deviation is also the same, 12 minutes. Let's do the calculation and check the probability. It says it is 69.15%, around 69.15%. So the probability that a person enters the store and spend more than 39 minutes in the store is about 70%. This area is almost 70% or 69.15%.